Huh? Exacto, muy buenas noches. Creo que está en el formato incorrecto. Mientras tanto, por acá, saludos, muy buenas noches. Bienvenidos a Doné Dominicana. No vamos a dar mucho detalle porque hoy tenemos un invitado que queremos sacarle todo el provecho. Yo sé que él debe estar en backstage ahora mismo, no entendiendo nada de lo que está hablando, pero no te apures, Ronnie, que esto es solamente la introducción. Ya casi vamos contigo. Si te estás conectando con nosotros por primera vez, mi nombre es Andrés Pineda, yo soy parte de la organización de Doné Dominicana. ¿Quiénes somos nosotros, Doné Dominicana? Doné Dominicana, la comunidad de todo lo que tiene que ver el desarrollo en tecnologías.net, Microsoft, base de datos, .NET, C#, qué código, qué Solid, como el ejemplo de la charla de hoy. Todo lo que tenga que ver alrededor del mundo .NET, alrededor del mundo Microsoft, nosotros estamos acá. GitHub Copilot, que tenemos una charla muy interesante que estamos preparando con una persona que trabaja directamente en GitHub y nos viene a dar aquí un detalle sobre todas las bondades que tiene GitHub Copilot para nosotros los programadores. El mundo está cambiando y como programadores nosotros tenemos que ajustar nuestros cambios. Pero mientras tanto tenemos que seguir aprendiendo porque ustedes han leído mucho que nos van a suplantar, que no. Mientras eso pasa, tenemos que seguir aprendiendo y por eso el invitado de hoy nos va a dar un resumen, nos va a dar una información súper importante para todas esas personas que quieren, que necesitan mejorar su conocimiento de arquitectura. En este caso específicamente en el mundo.net, pero si tú no eres del mundo.net, como veo personas conectadas por acá, igual esto te va a servir de mucho. Doné Dominicana, estos eventos no llegan a ustedes gracias a nuestros patrocinadores. La noche de hoy y desde que inició este proyecto, nuestro patrocinador es el agente de JetBrains, el creador de todos los editores de texto, independientemente del lenguaje que tú tengas. JetBrains tiene un editor de texto para ti, específicamente para .NET y para .NET, para C# está Writers. Writers que desde hace unos años, ustedes saben que está la edición de open source. Si tú estás utilizando Writer para open source, si estás utilizando Writer para aprendizaje, si estás utilizando Writer para eh, un proyecto sin fines de lucro, tú puedes usarlo, puedes usar la versión full sin ningún problema. Pero si tú necesitas utilizar Rider para un proyecto que va a producir dinero, vas a necesitar una licencia. Y adivina qué, gracias a la gente de JetBrains, nosotros tenemos licencias disponibles. Así que si quieres probar Rider, quieres usar Rider en un proyecto de pago y que no te genere ningún problema, escríbenos a nosotros y nosotros te vamos a hacer llegar una licencia. Nada, yo sin mucha espera. Rodney, hello. How are you doing,
Hello.
man?
How
Yeah.
you doing?
How's your Spanish doing? Spanish is so over.
So it's I can understand more. Like when you were speaking, I can understand more. But I really think if I just took myself to the DR for about a good 3 to 6 months, I'd be able to figure it out.
You should do it. Nothing is stopping you. You can work from anywhere, right? So
Yeah, you're
why
right.
not? Man, we're very happy to have you again. Here is another time that you have been here in the past, and as we were talking behind the scene, right?
Mhm.
It's always wonderful having the knowledge that you bring to the community. You are one of the very few people that this is a Dominican Republic meetup, so most of our presentations are in Spanish, but you are only one of the very few that we always bring because you're very close to us and personally speaking, and also for the community. So thank you again for saying yes whenever we say, Ronnie, we want you here.
I'm always happy. Like I said, we're friends. So anytime you want me to come speak about anything that I have knowledge of, I give it freely.
And the good thing is that two things, you're knowledgeable of many good things. And as I told you in the past, you are very good at explaining things and at making people understand the concepts.
I do my best.
Yeah.
And so that comes from like sometimes I can be the slow kid in the back of the room and I have to read things 3 and 4 and 5 times to make sure that I got it. And so I'm always having to find ways to teach myself. So I just try and explain it to people the way I do it.
Yeah. Yeah.
Yeah, but no, Rodney is not Dominican. Who's Dominican? Who's really Dominican? Charlene.
Yeah, you gotta be Prague, because Charlene is in the house. Hello.
Yes, I am.
You're seeing you're seeing this, isn't that right?
Yeah.
So hi to you wherever you are.
The joke is that she's giving me a Dominican name, and my Dominican name is Roberto.
Roberto.
So when she says Rodney's Dominican, no, Rodney's not Dominican, but Roberto is.
Robert. And you look like a Roberto, actually. People on the street, you would say, "Oh, what's your name?" "Oh, my name is Roberto." Say, "Yeah.
Yeah.
He checks out."
There you go.
Well, Rodney, I'm gonna leave you the stage.
Oh,
Because there's plenty of things to discuss. I'm gonna be here in backstage. Folks, remember, if you have any questions, feel free to ask your questions. I'm gonna forward the questions to Rodney. He's gonna be reading, but put it on the screen. Don't be shy. Rodney's one of us. So Roberto is Dominican. If you speak slow, he won't understand what you say. Well, if you type, but in this case, he's gonna be reading. Rodney, the stage is all yours.
Thank you. So I'll start this by saying I wrote this I did my slides in a different technology this time than I normally do. So we're gonna try this all together and see how it all works out. But today, this topic came about as a result of a conversation I had with a good friend of mine and an amazing developer, and she explains to me, Rodney, I don't really get what you mean when you say like all of this abstraction and why we need it and why we don't. And so we have a lot of conversations around this in our day-to-day because we work in a system that's important, that these things are important. And I kind of wanted to bring to light some of the modern things that I've been doing with C# that people may or may not be aware of. Because if you're not paying attention to the language features that come into the framework, you're not going to know like what's out there or really how to use it, because not everything is crystal clear. So we're going to talk about the abstractions, the lies, and a better I struggle saying better way, but a different way to approach some of the same problems that we've all seen throughout the years. Oh, I'm clicking buttons and it's not working. There we go. We're already starting off. Yeah, so you guys know who I am. I'm not going to go through it. This is just the slide that for people who don't know, but that's me. I write software for a living. I write software for fun. Software is like a big part of my life. Today, we're going to kind of go through this kind of quick. Abstractions, we're going to talk about what they are. We're going to talk about the dependency escape room. So like what happens when the dependencies become so much that it legitimately gives you a panic attack to try and make a change. Some guidelines around things that we could do better. Tools that modern C# has available for us. And I'm going to give you a concrete example that's actually out there in the wild. It's something that I've been using for several years. It's a set of abstractions on top of a C# build system that I've been using for some years. So that's kind of what we're going to go through today. So the disclaimer, I always put this disclaimer because, I was that guy where I'd go watch a talk and then I'd go try and like implement it. Don't go to work tomorrow and tell your boss, hey, Rodney said we need to do this, because I will deny it. I have evidence, right? There's a disclaimer. Take it, see what you can do with it. Try and understand where the patterns apply rather than just try to jump in, because this kind of emerged for me after looking at so much code rather than something that I woke up and said, this is how I want to do it. So the $64,000 question is why? Why should we abstract things? And this is where we're going to start talking about the lies off the bat, right? You'll hear all the top people say, oh, you got to do it to make the code more testable. Oh, you got to do it to make the code more maintainable. Oh, you got to use clean architecture. Oh, well, the seniors said we should always do, man. There's a very definitive answer to this question, and I find that most developers don't know it. So we're going to talk about it. What are abstractions, right? So the fundamental theorem of software engineering states that we can solve any problem by introducing an extra layer of indirection. Great, right? Fantastic. So what does that mean? That means that we can make a problem disappear by adding a seam by which it decouples a problem. So this is really the only reason why we should abstract, is if we're trying to solve a problem, not because it feels good. We're doing this because we have a problem to solve that we can't get around. And there's a balancing act here, right? Because if you over engineer stuff, you end up with so much cognitive load and so many dependencies that you can't think straight. If you don't adhere to some of this, your systems become extremely brittle. And the secret sauce, the mastery, is knowing when not to add that layer, right? So like if I'm looking at a piece of code and I don't need to add a layer, I don't add a layer. And this is actually kind of how this talk kind of formalized, because Charlene and I were having a conversation, and she says, Rodney, I don't understand why you wouldn't add this layer here. And I told her, I was like, I don't feel the need to add it because we don't have a problem to solve. Like, we're not trying to do anything with it. So why would we add it? We're just going to add this complexity because that's the way to do it. Okay. And that's how we end up in really, really bad systems. And this is why people say, oh, over architected and blah, blah, blah. It's not because things are actually over architected. It's because we are doing things from a dogmatic perspective instead of doing them because it actually makes sense. So
can I join the conversation really quick there?
Yeah, come on in.
And it is because I invited a friend of mine he's more in the Go land. And
Nice.
I say, you should come and you should listen from, because of some conversations that we have had in the past, is that why in .NET Word, everything is so abstract. There's so many abstractions. There's so many things, so you have the repository, the service, the unit of work, and many layers of things that are not resolving any problem. It's just most of the time they're just there because some senior decided that was the way that we should do things for some reason that the people who do it nowadays don't even know. Exactly.
The average developer doesn't even know why we use the repository pattern. They just use it because that's what everyone uses everywhere. Come on. Like, we can do better, right? Like we should do better. And let me rephrase. We should endeavor to do better, right? We should try our best to be better at our skill, right? So yeah, and that's the good part about this, right? Like, some of this isn't C# specific. The first half of this is really just about core principles, right? Abstractions, right? They're here to hide complexity, right? We have this big method and we need to move it out. Let's abstract it, right? Extensibility, being able to inherit and share behaviors, right? To be able to test things. Yes, that is a reason why abstractions are good, but that's not the reason why you create them. And then this whole decoupling of high level, low level policy, that's like the jargon that they use from back in the day. And I only put it in there because we're talking about the lies that they told us, right? And to me, I feel like that's one of the lies they told us. They talk about these big, scary software engineering or computer science terms that us normal people don't really need to care about, right? Tell me how that matters to my day, right? So what is an abstraction in C#, right? C# interfaces, right? This is they're one of my favorite. They're my favorite abstraction for this reason. I can decouple any two pieces of subsystem by sticking an interface in between it. I can do it with an abstract class, which we'll talk about, but it's not my favorite because it's not as thin. This is just a contract. This is like an SDK, right? I call this method with this input, and the documentation tells me it's going to give me this output. That's all an interface is, right? That's why I love them. In one of the recent versions of C#, I'm going to butcher this and someone's going to yell at me later, but I think it was 13. They added default interface implementations or interface methods, right? And like, now you can put methods on interfaces, which you couldn't do before. Oh, wow. So now if I'm actually looking at interfaces correctly, which we'll talk about, I can use that concept to do more things. And we have interfaces because C# doesn't support multiple inheritance. So sometimes interfaces is the only way to say that this thing adheres to this contract, right? Abstract classes, like I said, it's a class. It can't be instantiated, but it's a class, and that's the difference. So you can only inherit from one abstract class. It's another inheritance approach to try and share code and behaviors through a subsystem, and it uses a specific relationship type. I find uses for abstract classes, like when I have a big polymorphism chain, I'll use abstract classes. But if it's thin, anything under 3, I won't even bother, because most of the time you just end up coupling yourself in bad ways. Oh yeah. Yeah, I knew you would be that guy. Was it? No, it wasn't 8. 8. I thought 8 was no reference types. No. No, I don't think you're right. Google it for me and then tell me if I'm wrong. Be that guy. There's always one in the room, yeah? So let's talk about the lies they tell us, right? Interfaces are class contracts, and we do it for testing. And you just put it on the interface. You may not need it, but it's good to have it there. A single implementation warrants an interface because it might become polymorphic in the future. And an interface should represent the entirety of the object, right? Like, no, these things are not true. They're just flat out not true. Yes, interfaces can be used for testing, but like I said, abstract classes can be faked by any modern faking framework or mocking framework, very simply. So don't believe these things when people tell you that, right? So like the first real lie. Oh, default interfaces is in C#8. Man, okay, I got that one wrong. Oh, well, look, I love how the feedback is instant. Like, no, Rodney, you're wrong.
I was going to say that this is one of the very first time that I see people saying, oh, you're kind of wrong. And I love it because it makes you understand that people are paying attention, right?
One, people are paying attention, and two, right, it's an opportunity for all of us to learn and grow, because I can't remember what, like, I'm still on 11 in my brain, and I haven't taken advantage. 13 is collection expressions. I'm going to get that one wrong. Right, that's the next one they're going to yell at me and tell me I'm wrong. But like, yeah, I love that interaction. I don't care. Haggle me. It doesn't matter. Tell me I'm wrong. Yeah, I've been wrong before.
And it will be in the future.
Yeah, I'm gonna be wrong as soon as I get off of this live stream. Let me tell you.
Yeah.
I might even take that long. So there are all these lies, right, that they tell us, and they expect us to just carry forth this bucket of lies because that's how software is engineered. And I'll tell you, I've spent some time in some other languages. Recently, I've spent some time in some other frameworks, and some things I like, some things I don't. And sometimes I miss C# in its structure, and other times I don't. But there's a lot of things that they tell us that I feel like are just carryover, like this one from previous states of being, right? So like, I was a C++ developer and a C developer years ago. We used to have header files, and these header files defined the header files defined the behavior of a class, and you had to have a header file in order to have a class. And when I moved to C#, I saw people doing that a lot. Like, oh, well, we may not need it, but we use it because that's how we used to do things in the old before times. And I'm like, we need to grow. We need to do better, right? Does that? Yeah, that shows up good enough. So the whole Yagni principle, right? Like, you are not going to need everything on this service, right? Like, and if you do, then I would tell you that either you're doing it wrong because you're leaking too many things from your abstraction layer, or you need to break it up because this thing is now a God class, right? Like, it can do all the things and none of them are related, right? And we'll talk about why that matters in a little bit. Yeah, right. So like, I have a thing, and because I have a thing, I have an interface, right? Like that one implementation. Like, yeah, we may get to having thing 1 and thing 2 and thing 3 and thing 4 eventually, when they start popping up. But until they pop up, why would we put an interface for the thing when we don't actually need it? Like, it does us no good. Like, oh yeah, because we got to mock it for a test, but then you go to the tests and it's never mocked, right? Like, you just instantiate it, and it's like, oh, cool. Why do we do this? Yeah, no big deal. So it really gets into the whole concept where we're not really getting any lift out of this. And if we're not solving a problem with this indirection, why are we going down that road? It's just no good. Oh yeah. So this is also another thing that I used to do back in the days, and I'll be the first one to tell on myself. Like, these aren't things that I'm telling you that I saw or read in a book, or things that that I heard about through the grapevine. These are things that I've done incorrectly and have had to learn from these lessons the hard way. And this is one of the biggest ones right here. I used to have contracts on all of my interfaces that defined what the contract was. And while that's not inherently bad, the way I did it was not inherently good. So this way of doing it is actually flawed. And we'll talk about this a little bit later when I show you a different example. But all this does is say, I've got this set of properties, and then I've got a DTO that satisfies this set of properties. And I was thinking that, oh, and this was, again, in the before times, back in the oh God, the ASMX days, what was it? The Microsoft Web Service, WSDL's WCF, was it? I think it was. Yeah, there we go. This goes all the way back to those days where I was thinking that exposing a contract was actually giving me lift with my consumer, because I'm able to shift better. And I fed myself full of these lies for reasons, because, the people around me were feeding it to me, and that's how we do things here. And yeah, okay, great. But the problem with this is it breaks single responsibility principle. And it can force unrelated things into your ecosystem. So it's really not good to do things like this in this manner. So like now we're getting into kind of the concept of like the traditional approach that people do when they define behaviors, and kind of talking about a compositional approach. And this slide is probably out of sequence a little bit, but we'll get there. Because really what I want to point out is that we have these concepts of behaviors that we want to provide to consumers, but the problem that we run into and what we talk about is interface segregation and Liskov. Yeah, so I think somebody said that Rodney is going to talk about the I in solid. You are correct. The only 3 solid principles we're going to talk about today are SRP, LSP, and ISP. So if we look at this, anytime I inject an iUser service into a thing, now the entirety of that thing has the ability to access anything on that iUser service. And it's up to me trusting them to be a good person, not to accidentally save if they shouldn't save, right? Like, let's say we're getting a user for return to the user interface, and because we have access to the user service, the method can call save and have bad side effects, right? Like, those are bad things that we allow to happen when we do the traditional class contract approach, right? But if we break it up in a compositional approach, we can segregate the behaviors that our consumers depend on, which gives us the ability to have a much more granular system, and things are much more single responsibility in the long run. So this kind of gets into what I'm kind of calling like the domain composition approach. I don't know if there's somebody smarter than me who's been doing this longer than me that has some moniker for it already, but I just came up with one, and I'm sure somebody will find me and tell me, hey, Rodney, there's already one. Here's the guy, or here's the lady. But here it comes. So composition isn't just for like, building systems, right? Like it's about interaction between subsystems, right? And what these interfaces should describe is what they have, right? What they own, or what they are privy to, and what they are capable of, what they can do, right? And if we describe our system in a manner of I have and I can, or I will, and really you don't want to get into like subjectives like I will and should, because it gets kind of weird, right? You want to make it demonstrative. I have these things, I can do these things, right? And giving us the ability to look at our system that way allows us to construct a composable domain or a composable system, whereby we take the pieces that we need, adhering to interface segregation principle. We take the pieces that we need, and we only give consumers access to those contracts and those portions of the contracts that they need to do their work, right? That also supports Liskov substitution principle, because now if my interface is granular enough and I do it correctly, I can I can ensure that when I go to substitute, I'm substituting with the right polymorphic object and that it won't break anything. So now we kind of get into the whole concept of composition versus inheritance. If you've been around the block like me, you've heard people talk about composition over inheritance and blah, blah, blah. And I'm here to say that like both are needed to build a modern system. But the problem is that we talk about it in a competition perspective. And I don't think that it should really be competition. It's about relationships, right? Composition says, I have this thing. I am responsible for it. I'm a steward of it. I may own it. I definitely have to pay attention to it, and I have access. And I am is really about inheritance, right? Like I am my father's son, right? So I inherited some of his characteristics. I inherited his height, for example, right? Like I inherited some of his behaviors, right? He has certain behaviors that I have, the exact same behaviors. It's almost scary at this point in my life, right? So what we're really talking about is the relationship between objects. So we shouldn't talk about it in a versus like, oh, I'm going to use composition or I'm going to use inheritance, right? We should use composition and inheritance to share behaviors in a way that makes sense for our consumers. And there's a gang of four, I think a behavioral pattern around this, and I can't think of the name of it off the top of my head, but it kind of bridges the composition and the inheritance and gives you the ability to kind of bridge that gap. And it's an interesting approach. I don't always use it, but it's an interesting approach. Yep. So here we go. Solid. So yeah. So SRP, right? Single interface, single behavior. If I start coupling multiple behaviors onto a contract, then I now have to ensure that every consumer of that contract maintains those behaviors when I need to refactor. If I keep a single behavior to a single interface, then I don't have as much risk with coupling my concerns. And we'll get into what that matters in a minute. LSP, Liskov substitution principle, right? So we can cleanly inject that behavior. We can inject it into the subsystem, and the subsystem is none the wiser about the rest of the things that an object can do. And that's kind of important, right? Because, and we'll talk about this in a minute, because of the way that the modern C# approach does this, when you use default interface methods, what you end up with is the only way you can access that method is from that interface. You physically have to cast it, which means if you inject it as the interface, as opposed to trying to do is or as in like a switch statement or if block, you can get clean injection of behaviors and not worry about consumers having additional information that they shouldn't have. And then the interface segregation is legitimately the secret sauce of this whole concept of composition, because we can isolate every single interface. It allows us the ability to describe behaviors in a singular manner. So basically, interface segregation principle is the lift that allows us to enforce Liskov and single responsibility. And without it, we wouldn't be able to do this. So we get to the fun where we talk about coupling and cohesion. And I'll just go ahead and say that these words didn't mean anything to me when I first heard them. I was like, okay, yeah, coupling, cohesion, whatever. And then I read the definition and I was even more lost, right? So the concept of this is how we should organize things, right? We talk about interdependence and the degree to which they belong together, right? What we're really saying is, if I have to brush my teeth, I need toothpaste and a toothbrush. I don't need toothpaste or a toothbrush. I need them both, right? So those things are interdependent. They're coupled together to do the thing of brushing teeth, right? But those elements also belong together when we talk about the domain of brushing teeth, right? When we're talking about flossing, yeah, it's in the domain of teeth, but it's not in the domain of brushing teeth. So we shouldn't add the floss bit onto the interface to make it, oh yeah, well, you got to floss too. No, we're just brushing teeth, right? So like, toothpaste and floss don't go together. Why would we create an interdependence between those two things? to get to the point where we brush teeth. And I use that example because it's a relatively straightforward and easy example to get. And it came to me one day while I was brushing my teeth. And because of the way that my wife likes to store the teeth brushing utensils. So she's going to hear this later and she's going to laugh at me about that. So coupling and cohesion are really just, we talk about, we want low coupling, high cohesion, right? So we want things that belong together to be together, and we don't want things that shouldn't depend on one another to depend on one another. This is a direct correlation to interface segregation principle, Liskov substitution principle, and single responsibility principle. That's really an approach to what these things are talking about, in my opinion. So again, we talk about representations in modern C#, and we kind of have them in the inverted order. The newest one is default interface methods. Before that, they gave us extension methods, but there's a new extension behavior or I think it's a keyword, and I'm not well versed with it, but it's a new way to do it. So I'm not going to talk about it here because I haven't used it. And again, I don't like to talk about things I don't use. And then we're going to talk about interface overlap, which is the number one thing that I get pushback when I talk about this concept from people.
I just want to add there that if you want to know more about this new way of working with extension methods and properties, Lester Boteo, who is in the chat, was explaining that like 1-2 videos before. So if you go to this channel and you go in reverse, one of the last presentations when we were talking about the new features for .NET, the .NET Coms summary, you will see Lester explaining. So after this, go and read it.
Even better. Yeah, let Lester explain it to you because he uses it. I don't. So I'm not going to sell you any more lies, right? That's the point of this. We're uncovering the lies. We're not adding more to the pile. So this modern representation, right? Like, oh, see, there it is. It's in the slide. How about that? So I got to write somewhere. There are drawbacks to this, and I'm going to jump directly into it because again, you'll see examples of how it works in a little bit, but the long and the short of it is that it's not a replacement for abstract classes. But it's also not extension methods, right? You're actually adding behavior to the physical contract, which is something that C# never allowed before. But the when to use it, this is the important part, right? Like when you're involving APIs, right? Like this becomes a convenience thing. And if you've used a language that has a concept of mix-ins, this is kind of where this gets into the concept of mix-ins. I'm also not going to talk about that because that's a whole nother conversation, but it's one of those things where you'll see it when you see it. So again, the fine print, right? So interfaces can't have fields. They can't hold state, right? So they can't manage state. So that's a very big thing. So there's limits to what you can define on some of these behaviors. You run into the diamond problem, and you have multiple inheritance, and you get a little bit of ambiguity. So like that is one of those things where it's like, okay, where is this behavior defined? How do I find it? Some of the modern tooling alleviates this, but it is still a thing to call out. And you sometimes have to bridge class state and interface behavior. So it gets kind of weird. Sometimes when you want to assign state, you may not actually know what the state is at the time. And then the discovery gets weird because even though you can override it with I think a virtual, or you basically you can override it with you can use the virtual approach and use the override keyword to override the interface. It still may be weird trying to discover where the behavior is actually going from. So if you're making this decision, you're having to make a conscious decision that you're using this, and you need to alert your developers that this is a thing that you're subscribing to. You can't just put this in like one place and not tell anybody and expect everybody to know, because you'll crash production. Again, we've done it. We crash production by adding, not production. Sorry. We crash QA by adding a default interface method in the early days of MAUI, and some of the cross transpilation didn't work correctly to iOS, and man, something really innocuous started blowing up, right? So and we hadn't told developers, right? So again, Rodney is laying out his sins in front of you. I've made these mistakes. Don't make them. Learn from my mistakes. Don't do it yourself, please. again, extension methods, they add methods without like actually modifying the type. So that's the draw to it. It is kind of like your fluent patterns, but it's still not instance methods, right? Like you don't have access to certain things. You can't override certain things. So you don't really have access to everything that that an interface or a class would have access to. So that's a big call out for extension methods. And this is kind of like the whole interface overlapping bit. When you have small interfaces that have specific descriptions, right, you can potentially have things that overlap, right? So you may have let's call it just an ID method, right, or ID property. You could potentially have an ID property on interface A and an ID property on interface B, and as a result of that, you may have some problems with trying to access those things. There is a technique in C# where you can explicitly implement an interface. So you have to kind of use that approach in those scenarios. The other thing is with the interface overlap is that sometimes you may want to share behaviors, and that's when you may want to shift certain behaviors to like an abstract class. And interface segregation may not give you the lift that you want. So if you're trying to share those behaviors and the ISP isn't giving you the lift you need, then you might need to look at a composition inheritance approach. So here's an example of interface segregation in a way that shows that overlap, right? Where thing one, or like the first version of our contract only had a name, but the second version of the contract has a display name, right? So now when we apply that overlap, name is now ambiguous, right? And the compiler will tell you, oh, you need to pay attention to this, and it's a bad thing because it won't know which one to access. So this is when you want to use that explicit interface implementation, and then you can have thing v1 and thing v2, and clearly demonstrate how that works or what the behavior is supposed to be in the class. So this is kind of a jump in, please.
I want to ask you something here.
Yeah.
Why did you choose? This is the questions that I get asked very frequent, but I wanna listen. Well, I want people to know the questions and to understand the reason why. Why are you doing V1, V2, and why is not V2 inheriting the interface from the first interface, and then you just have to inherit from one?
Oh man, you just walked into a hornet's nest that may detract us, but this is a great question and I'm going to answer it. So for the context of this particular talk, there's actually no reason. It's just an oversight, right? But let's talk about the techniques, right? What Andres is pointing out is that I could have thing v2 inherit from v1, remove the name property, and then now I kind of remove that problem, right? But now if thing v2 actually has a different behavior than thing v1, I can't separate those behaviors.
And this is when implementations ends up with the throw not implemented sections, because you have to follow the contract, but you're not actually following the contract to the specs.
Right. And now and now what you're causing is a list-off violation. Right?
Exactly.
Like as a result of that.
Yeah.
So it's great that you asked that question, because list-off substitution principle, in my opinion, is the hardest one of the bunch. But it's honestly one of the most important that we don't really pay attention to. And again, on that, I made that mistake, right? Like where I have a API contract and like I do this and I have V1 and V2 and I have V1 inherit from V2 because it should just inherit all those behaviors. No. V2 has different behaviors and it can share some of those behaviors, and where it makes sense, I should find a way to share those behaviors. But in reality, no, they are different behaviors. Flat out, they are different behaviors. And we need to ensure that we have the ability to project that to our consumers. So there's many different ways that you could slice this, and a lot of them are wrong. Few of them are right. But it's really all about what your requirements are. So I won't say that one is definitively wrong or one is definitively right. You got to figure out what makes sense for the requirements that you're given and the problems that you're solving. Because remember, the fundamental theorem of software that we talked about at the beginning, you only add the interface as a reason to solve a problem. So if versioning is the problem you're trying to solve, then, look at the requirements of your versioning and plan accordingly. Great question. Great question. You made me talk about Liskoff. So happy. So how you can see this is I've been reading about this new query object pattern recently, and I'll say I'm not a fan, but I am a fan. One of the biggest problems I see in like 90% of the .NET applications is repositories start to depend on other repositories, and the reasoning behind it is, well, we want to maintain the behavior, but we don't want to duplicate it, and it's an interface, so we can just inject it. And the answer to that is no. Behind that interface, somewhere in your DI setup, there's a concretion. And I've seen instances where we end up having to lazily inject things because we've created a circular dependency reference because we have repositories depending on other repositories, which becomes this ridiculous nightmare, right? So one of the patterns that I've seen recently is where you break those things up into interfaces and you create individual classes for those concerns. And I'm going to kind of bridge the gap between that. And I'm going to show you a concept of a context that implements each one of these. And this is actually using the explicit interface implementation, right? For the reason that when I'm going to bring my mouse up so you can see it, for the reason when I inject this session context, it's going to come into my object as an I create session. So now, because I have it as an I create session and I've done the explicit interface implementation, it just makes it easier for everything to resolve, right? It also gives me the ability to do template method pattern and other types of things to share behaviors via inheritance if I wanted to. But again, only do that when you have the need. It also gives a clear indication that when this session context comes in, this is the only thing you're going to get. This is the only thing you're going to get access to. And it's very clear to the human looking at it that's the contract. Otherwise, you would look at this as a public method on the session context. And if you were to go and actually new up a session context and give it a DB context, guess what? You won't have access to this method because it's explicit to this interface. So that's a very important thing when we talk about interface segregation and the Liskoff violations, right? Because now we only give consumers what they need to do the job we expect them to do. And if session context needs to be the same instance, we can handle that in our DI configuration. That's not a concern. And again, we're not going to talk about dependency inversion, but that's not a concern for the way we write our software. We can abstract that to the dependency, which Solid tells us to do anyway. We talk about third-party seams, right? So like now we're getting into this nuke example, this build system example that I'm talking about. And this is kind of like a teaser. Again, some of these slides are slightly out of order, but we'll talk about the traditional contract versus the composition approach. There's trade-offs, right? There's no clear this is the way you should do it, right? But these are some guidelines, right? When you are prototyping and you're trying to move fast, go for it, right? But it has downfalls of, rigid coupling and making God objects. So as you go through your refactoring periods, separate these things out around boundaries to get single responsibility adhered to, right? The composition approach, it's very focused. It's highly reusable because we are making single methods that have things that they do. It's an explosion of types. The discovery process can become, again, like I said, if you don't know what you're looking for, it becomes very different because it's a modern pattern. And you don't run into that the limitation of no state. So that's the kind of like a compare contrast. But why I came to this pattern is actually because I work on a build system. Or no, I don't work on the build system. Let me say I use a build system and I have an abstraction around that build system called Nuke. And Nuke is a C# build system that I have been using for some years. Prior to that, I used Cake. I love both of them for different reasons, and I use them for different purposes. But this came about as a result of the abstraction that my friend David Driscoll and I started building on top of Nuke. And this is going to be like this practical walkthrough of this thing, right? So like we realized that we needed to stack this like Lego blocks, and I know I have it stacked and it's sideways, but it didn't fit on the screen otherwise, so I did it sideways. We wanted everything in our system to inherit from the interface extension point that the build system gave us, right? And what this comes down to is that we started to realize that we had behaviors that owned certain things, and we wanted to provide the access to things that could act on the things that were had, right? So we understood our inheritance and our composition, and we were trying to find a way to make a build pipeline from the composed bits, right? So we got down this concept again, like I have and I can, right? So we have a solution, right? We have a Git repository. These things are singular, and certain aspects of the subsystem, right? Certain can methods need the solution, but they don't need the Git repository, and vice versa. So we singularize these behaviors so that we can give access to things that needed it, right? So like when I can restore with .NET Core, right? The only thing I need is access to the solution. I don't need access to the Git repository. So I can set up my composition in a way that gives this interface, and again, we're still in the interfaces. We're still just defining contracts. We haven't actually started defining concretions, right? But now we can give behaviors, default behaviors to these contracts. So now anything that it implements or extends from I can restore with .NET Core gets that target .NET Core restore by default. And it gets the actual behavior, not just a contract for the behavior. And I think this is where modern C# interfaces are bridging the gap for me between abstract classes and old school interfaces. But now this allows us to chain these behaviors, and now my build, which needs to depend on a restore step, right? Because like now, again, .NET clean, .NET format, .NET restore, .NET workloads restore, .NET build, right? Like this is the way that you're chaining your pipeline. Now, as you state what things can do, and this goes back to Andres's point, right? Like in this scenario, we decided that that layer of coupling was okay because you can't build without doing a restore, and we don't want the build method to do its own restore. We want to control the restore behavior, right? So now, even though we are bending or leaning on Liskov substitution in a bad way, we're doing it because we're trying to solve a specific problem with these abstractions. Again, when you have cross-cutting concerns, you create these single interfaces, and it makes the entire approach much easier to deal with, right? Because now we're talking into things that have versioning, right? So we may not even get to the versioning step. So why should the stuff that doesn't have anything to do with versioning get knowledge of the versioning? Nuke, the creator, actually saw what we were doing. I showed him what we were doing with some of the interface segregation in this, and he actually created an inherit method into the extensibility of the framework that gives us the ability to define a target and inherit from a target. So now this just boosted our ability to do this in ridiculous ways, because now I can provide additional behavior. So now, like what we talked about earlier, the template method pattern, that's basically what this is. This is giving us the ability to run a set of things and then kind of add additional behaviors to the base behavior. I'm being time conscious. I know we started a little late, but we're running up on time. So, but like the comprehensive composition approach now is, right, like now you see my Nuke build, and I have composed it of the things that it requires in order to do its job. And when I get to the default target, I no longer have to, like, again, this is where the discoverability problem comes in. It inherits all these behaviors, but it doesn't define the behaviors. And I think that's the point, right? I can now define these behaviors in interesting new ways and allow my actual classes to have thinner surfaces and keep the responsibilities singular and away from places that they don't belong. So while it is a little bit harder to discover, in my opinion, it's much more cohesive. And again, that's probably part of the problem with cohesion anyways. the discoverability, pardon me. But that is what this looks like in practicality. Now my build doesn't have to define all these methods to get things done. It only has to define the behaviors it cares about. And I think that's the real secret sauce in this composition approach. This is just a fun method that you guys can go back and look at later, but it kind of shows more of how you can set public API surfaces using some of the JetBrains tooling. And when you look at the how, right? You can do certain things, like this is doing allowing us to compose parameters. We can also compose actual behaviors. This kind of, even though it's still a lambda, so it's technically still a property, it represents a function, so it's technically a method. So you're technically doing like method behavior substitution at this point. But this is kind of what that composition approach looks like, right? Where we are chaining together things that give us access to new things, right? So now when we want to microtize things, we can grab just the I have get version, or we can have the I have build version, which we know has everything that we need access to. So it gives us this ability, again, these Lego blocks, right? Like, so now you become that master builder. You get to compose different pieces with Legos and come up with this amazing system. And while it may not be by the numbers in the way everybody else did it in the entire industry, because, you know, they got the same cookie cutter documentation that everybody else has, yours is composed based upon your requirements, which in my opinion is much more robust. So what do we really talk about today? So we talked about abstracting with purpose, right? So that we don't end up with abstractions for the sake of abstractions and end up with, you know, anxiety behind changing an abstraction and have to, you know, call 3 different architects to make sure, hey, can I put this new method here without making a breaking change? We talked about composition over inheritance, but again, I put it here because that's how the industry talks about it, but we should be talking about composition and inheritance, you know, and describing our behaviors. I have, and I can. I'm clicking, see, there we go, clicking buttons incorrectly. We talked about interface segregation, keeping things granular. We talked about Liskov and how not to break your API behaviors by inheriting from the wrong things. We talked about how to leverage default interface methods to create behaviors that you can use to compose more complex objects in a way that C# never allowed us to do before, and kind of like gives you this superpower, so to speak, because you couldn't do this in like C# 2.0. It was just like, you could do it maybe, but it was just like the juice wasn't worth the squeeze. It was just not worth it. So really at this point, like, I have nothing else. Like, so are there any questions? Anybody feel like they actually gained anything from this, or was I just blabbing my face?
You tell me. I learned a lot of stuff. And it's funny because when you were talking about cohesive at the beginning, and you say you didn't know anything of that when you started. Neither did I, and that's the one of the benefits of the community, because a lot of the knowledge that I got was not even in work, was connecting to you and connected to other folks in the community.
Exactly.
And the opportunities that I had for work related, Chase been there, conversations with Chase outside of work. I mean, right. I'm telling, and this is for people that are listening this, it's good. And for some people's work is only go 8, leave at 5, do my stuff, and I leave. But if you ever have the opportunity to sit down, have a coffee chat, you remember how we used to have the coffee chat, and have conversations like this one, trust me, you're going to learn a lot, because you're getting outside of what the requirements of the company is, and you're talking about what, software developers should know in general.
Yes. So this was a fun talk for me, because it's one of those things that I had to learn all of this the hard way. I made these mistakes. I pushed code to production without knowing what I was doing.
Yeah.
So, and it's one of those things where, you kind of come full circle when you start, you're like, oh, abstract all the things. And you get to a point where like, oh, maybe not. Like I'm at the point now where it's just like, I don't really want to abstract unless I have a reason to, because I'm going to, sometimes by abstracting too soon, you can cause other problems, which we didn't talk about, but
Yeah.
those problems, that's when the panic really starts to set in. So yeah, abstracting too soon becomes a very, very bad thing when you get into
And
large scale complex systems.
and to bring to the conversation, because pushing to production without knowing what is happening is something that is happening very frequent these days.
Mhm.
So now more than ever, you got to understand that if you're using AI, I love AI,
Mhm.
Rodney love AI, everyone loves AI,
Mhm.
but you got to make sure that you understanding whatever with AI is producing to you. And I mentioned in the past that this abstractions is very common in the .NET world. So that means that the code that the AI was trained with has all these abstractions. It's gonna, the AI is gonna produce these abstractions because that's the way the code the AI used to be trained uh look like. So whenever you don't need an abstraction, you can tell in your in your Copilot file, whatever AI you using, use as lower abstraction as possible, or
Mhm.
use zero abstraction unless we need it. You know that you can put instruction in your files, so the LLMs understand your way of approaching problems.
So 0x_f0 has a very interesting comment, and I'm not, and it's interesting because I'm not quite sure I understand it. So he's saying that what he's going to start doing tomorrow is not doing interface implementation couples for types specifically used via dependency injection, and start implementing these explicitly with no interface at all. So yeah, you can do that, and there are techniques to do that, and I'll never say that it's wrong, right? Again, um, you do what makes sense with your requirements, and I honestly think that you're trolling me, to be honest. But um, the things that work for you may not work for me, and vice versa. So take everything I said today with a grain of salt. Use it, don't use it. Let's think about it, don't think about it. Uh, if it helps you on your journey as a developer, great. If you hear it and you're like, this is ridiculous, and especially in the AI world, right? People, the argument that I hear now is, oh, uh, sorry, use trolling. The, people say, oh, architecture doesn't matter in this AI world. And I beg to differ. I think architecture actually matters now more than
More
ever,
than ever, yeah.
because if
Yeah.
you don't have a way that to structure your code, and you're not writing it, just like when you write stuff on a piece of paper, you remember it better, right? When your key fingers hit that keyboard and you write the code, you remember the code you wrote. Now that AI is generating that code, you don't remember.
And something else, AI keeps learning with the code. So
Mhm.
if you start building something that looks spaghetti, the post interactions that you're gonna have with the AI is gonna be spaghetti, because that's the architecture that you define from the beginning. If
Yeah,
you're not using, if you're doing all crazy stuff, when you ask AI, any of them, to do a new feature, it's going to follow the same pattern that you define. So if you don't have a clear architecture
right.
or predefined and well architecture, it's going to just go and do all the stuff that you might not want.
Exactly, exactly. So I'm actually of the opinion that things like this matter now more than ever. And the hardest thing, like you said, is describing it to the AI agents so that they understand what it is that you're trying to do. And because it learns, right? You just, hey, you didn't follow this pattern. Hey, you violated this. Hey, you violated that. And train it to not violate those things. It'll give you amazing lift, because eventually you're gonna have to go look at that code. Eventually you're gonna have to go find some bug in it somewhere. And if it's not laid out in a way that makes sense to you, good luck.
Good luck. Yeah.
Good luck. Anyway, that's all I got for today. Thanks for the opportunity, as always, to sit and share some thoughts, as it were.
Yes. And again, if you have questions, this is still the time. If you don't find yourself having like the right questions now, you can always reach out to me or Rodney. or to the whole .NET community and ask questions. We're a community that we are very open. Also, if there's anything after this presentation, it'd be nice to talk about something else, because you got inspired because of the conversation. It was a lot of list code. For those that doesn't know about Solid, we did a presentation a long time ago about Solid. Andres Pineda make the presentation. Yeah, me myself, like long time ago. If you go to the channel history, you will see that. And there was another presentation made by Claudio. Claudio, the presentation was about like all the stuff that are not only solid. I don't remember the title. It was like a beyond solid, like things that you should know as a .NET architect, as a .NET developer, that are not only solid. And that was also very interesting. So all those presentations are in the channel. That's why we always record. If you're watching this recorded, thank you for the support. For everyone that is live here, again, thank you very much for being here, Lester. Good to see you. We should chat sometime. Me, you, Lester, Jose Gregorio, as well, and get a
Up, man. Let's chat.
yeah.
Thank you everyone for being here. Thank you for the feedback. Thank you for the questions. I appreciate the community more than I can express. I am grateful to have a platform to talk about software, in all honesty. So thanks, and until next time.
Yeah. So see you later, Fox, and thank you very much.